Perfect. All right, so we will get started. It is 6 o'clock Mountain Standard Time. Thanks everybody for joining us, and just welcome everybody to saltlakecity.net. Our website is below, so you can catch us there. You can catch us on the meetup group and see the different events and contact us there, if you will. First, I will discuss the agenda. So we're just going to have a little welcome. Then Tor is going to talk to us about demystifying authentication in .NET Core. And then at the end of our presentation, typically we go around an hour, but there's always some discretion there, questions, etc. There'll be prizes at the end. Just some housekeeping things. So if you're looking for all of our talks are recorded on YouTube, so you can find us under the Salt Lake City.net user group. There's also a link there to that. Those are posted after the fact, so that will go up once this is edited, and then it'll go up to YouTube. Feel free to ask questions using the chat feature on Teams, or you can verbally ask questions. I'll also be monitoring that chat to help out Tor, so he doesn't have to look for the tiny notification for questions. You can ask questions in real time, so that way, while it's fresh in everybody's mind, we don't have to go back to something that was presented early. Also, if your place of work happens to be hiring, or if you know of a place of work that happens to be hiring that could be interesting, feel free to post details in the chat. Share that with us. So first, let's just a little bit of a background about our speaker, Tor, who is an independent educator and consultant through his company, TN-Datakonsult, where he specializes in training developers in .NET, web security, OpenID-Connect, architecture, and more. Tor regularly shares his knowledge about .NET on his blog, which you can see the link right there. And he'll also focus on security, Azure Cloud, and authentication. So on that note, I think we can get started. So I'm going to stop sharing my screen and hand it over to Tor, who happens to join us from Sweden. So thanks again for joining us at a late time.
Yes. Okay. So I hope you see my screen.
Yeah.
Just to do that, great. So nice to this is my first user group talk in the US, so it's always fun to do that. So my name is Tor Nestenius. I'm a Microsoft .NET MVP, and I want to talk about authentication. So let's first talk about me. So I do a lot of training and teaching and coaching to developer teams all around Sweden and also outside. I do a lot of blogging about authentication, .NET and C# and a little bit of Azure as well on my blog. And I'm also an organizer of the .NET Skåne. It's a Swedish meetup user group like yours for .NET developers, and we try to host monthly meetups. When I do training, I do a lot of training from everything from .NET to architecture to web application security, and also lately I'm working currently on an Azure class for developers. That's my current kind of a project. So I do a lot of training, and I've been doing training for the last 14 years. So, and also important, do ask questions or feel free to interrupt me, because I really think that, the discussions with you is always helpful and interesting. And, so just write in the chat or ask directly. That's fine with me. So let's talk about, what the goal of this presentation. And let's talk, about the classic ASP.NET Core application. We want to sign in a user. We want to be able to log in. We want to be able to show the name of the user. We want to be able to sign him out and similar. But how do we do that, and how do we get to this point where we can display the user's name on a page? There's a lot of things going on under the hood, and the goal of today is to try to clarify, demystify, and explain, how things behave under the hood and how we can end up with the name Bob in this case. So, and to insert that name on the page, we, can simply ask, insert the user's identity and get its name. And then, of course, okay, what is a user, what's an identity, and what is name, and all that, it's still, a bit a mystery. So the page needs to be able to display this something for the claims principal, and that object represents the user's details like name, email, user ID, roles, and similar. So what is a claim? A claims principal. So a claims principal is actually very simple. It's a list of identities. So yes, you can be signed in with multiple identities at the same time in the same claims principal object. So this object is the thing that we actually do, send to the page, and from that we can extract in the name, for example, of the current user. Okay, but we also see that it contains a list of claims identity. So what is a claims identity? So a claims identity is basically a list of claims. Okay, there's a list of lists here. Okay, so we have a list of claims. So what is a claim then? Well, a claim is just some facts about the user. Might be the user's identity, like user ID, name, email, role, or similar. So claims can be anything you like, and it's up to you to define, even though there's a few standardized claims that you can use. It's mostly up to you to fill your claims identity with claims, and then you can add those claims to this claims principal object that you then can pass to the page to display the current user. So I hope so far everything makes sense. So claims principal is a key object that we need to understand what does it represent. So it represents the current user. Okay, so but then the question is, okay, who creates this claims principal object? So let's try to clarify that kind of mystery. So to understand that, we need to go a bit deeper into the ASP.NET Core request pipeline and understand how it works under the hood. So internally in ASP.NET Core, we have a request pipeline. And in that pipeline, we have a set of middleware modules. And so that means that when a request comes in to our web application, our Kestrel web server here will create an object, an HTTP context object based on the incoming request. So that is kind of, created. Then that context object is passed through all of those middleware modules. And finally, it usually ends up on MVC middleware. And that one will take this object and then, render the page. And in other words, you render the view and then create, a response back. And then that response is then sent back to your Kestrel web server. And then finally, that becomes, your response that you send back to a browser. So this is how ASP.NET Core works, on the lowest level. And in our case, we have an authentication middleware that is in charge of creating this claims principal object. And that object is kind of added to this context object. So basically, that means that when the request comes in here, it's the user in this context object is anonymous. There's no user, there's no claims principal, there's nothing. And then it's up to this authentication middleware to decide who is the user, to extract and get all that information, create this claims principal object, place it into this context object here, and then pass it along to the view and then back to the browser. And hopefully that, makes sense. And usually, then the question is, where does this authentication middleware get its data? Usually it is from a session cookie. It can also be from access tokens if you're using OpenID-Connect or similar, but usually it's either the session cookie or the, tokens in different forms or shape. And just to have something to demonstrate, I do have a simple application here, a plain ASP.NET Core application. Right now, there's no kind of logic. We do have a secure page here, but there's no kind of security on it right now, so we can just navigate it to it even though we are not logged in. There is a simple login page, but this one does not really work yet. And we will, step by step, add authentication to this application, and we will try to reason about each step along the way. So in our case, we wanted to add this middleware, authentication middleware, to our application. So we first register all the services in our DI container, and then we add the middleware module to this request pipeline. Basically, what we want is to add this module to our application. And we do that by, let's go to our application here. We need to add the, so if I just copy this thing here. So I need to go up here. We need to add authentication to register the necessary services. And then we add the use authentication down here. And obviously, just running this application now will not do that much good. There's no really logic, but we have, set the foundation for the coming modules. So right now, that means that we have added this authentication middleware to our request pipeline. Okay. That's good, of course, but what's inside this authentication middleware? So inside this middleware, we have a set of handlers, authentication handlers. And if you have played with ASP.NET Core before, you have maybe seen that you can do add cookie. Then that means that you will have one cookie handler inside your authentication middleware. You can also add the JWT bearer handler, and that is for when you make an API, then you can use that handler. Or if you're using OpenID-Connecting, you will usually combine two handlers. So you would have one OpenID-Connect handler and a cookie handler together. But we will not cover that kind of case in this talk today. That we could cover some other time. So usually you have one or two handlers inside this authentication middleware. And in our case, we will add the cookie handler to our application. We will specify where do we log in. We will also specify logout path and a path to show if we are denied access to a given resource. So in our case, we go back to our application here. We copy in our cookie handler like this. But still, there's no really kind of any good behavior in our application, so we don't need to run it right now because there will not be any kind of visible change in the behavior. But at least we have added the cookie handler to our application. So, and we will be kind of, talking about how do we use it in the next step. Okay, so far we have added the middleware to our application. We have added the cookie handler inside this authentication middleware. Okay, so far so good. Okay, so let's talk about what can we do with this authentication handlers. So these authentication handlers, or maybe one step back, the authentication middleware supports 5 different operations, 5 core operations. And the first one is authenticate. That one is called on every incoming request. And its job is to try to figure out who are you. And usually it takes your authentication cookie and and from that create the ClaimsPrincipal object. That's the only role for the authenticate operation. So that's one. We have a sign in, and that's all about remember my information. And typically when we call the sign in on the cookie handler, that means that we will set a cookie in the browser of the user. We have a sign out, and that means that we will remove the authentication cookie. That's all it starts. That's all it does. We have a forbid, and that one means that if you're making a request to the application and you are not allowed, you have you have an identity, you have a cookie. So that means that if you have a cookie, you send it in to authenticate, it creates a ClaimsPrincipal, but you're not allowed in because you're lacking some role, for example. Then your application or the authorization middleware might call the forbid operation. So, and then it's up to the cookie handler to handle that, and that usually means that we will redirect the user to the access denied page. And finally, we have a challenge, and that means that you make a request to your application, you do not have any identity, you don't have any cookie, you are anonymous, and then if you're required to be logged in, then you would be calling a challenge, and the challenge means, you ask the user to log in somehow. And if you're using the cookie handler, you're usually redirecting the user to the login page. So I hope this makes sense. And if you do have any questions, write it in the chat or do interrupt me. Okay, so these are the 5 core operations, and we should, if we're building authentication systems, we need to understand those 5 operations. Okay, so in our case, we want to secure our, secure page, and we will be doing that by adding this code to the, secure index action method, so that if we are not authenticated, then we will challenge the user. So that means that if we go back to the previous picture here, that means that we are coming into the application, we are not authenticated, and because of that, we will call the challenge operation. So we will add that, and that one will, eventually redirect the user to the login page in our case. And also all the code that I will use here, I will provide a link to the code after this presentation. So you will get all the code that will be showing. Okay, so we will add this to my application. So in my secure controller, right now it's pretty kind of plain. We add this logic to challenge the user so that when I can actually copy my thing here, no? Maybe I need to, yeah. Using, so this we challenge the user, we cover challenge on the authentication middleware, and it will kind of, then challenge the user to log in. And if we were to run the application now, we would see the following, I hope. Let's see if I can get this to work. So let's restart it. So now when I go to the secure page, I will be redirected to the login page. And that is done by the authentication middleware and the cookie handler. Because when we do this thing, we call the challenge to the authentication middleware. And in that one, we do have the cookie handler that receives that challenge. And right now, it will use the login path to redirect the user to that page. That is what happens right now. Okay, so far so good. But we also have something called schemes that we need to be aware of. Because if we have, our authentication middleware, we have maybe 2 handlers in our middleware. We need some way to map. So when I do a challenge, for example, in our case, we need to map who will handle it. Is it that one or that one? We need to configure which handler do what. So maybe we want that one to do the challenge. For bit should go here, sign out should go here, and sign in maybe should go here, and authenticate maybe should go to this one. So it's all up to us to configure this, who will do what operation, because you might have more than one handler in your middleware. So you need to do this mapping. And that is where schemes come into the picture. So that means in this case that you, on your add authentication operation here, when you configure it, you can define who will handle what operation. So for example, if you add 2 handlers to the system, you can give them a unique name. So you have cookie and OIDC in this case. So this means that with this configuration, we get what we see here on the right side, that we want the cookie handler to do everything except the challenge part. We want the OpenID-Connect handler to do the challenge. Please ask the user to log in. So this is a very typical setup when you use OpenID-Connect, like Identity Server or similar. So in our case, we only have a cookie handler, so we can set the default scheme. That means that the cookie handler should be used for all operations, and it will be it. Actually, in our case, we don't need to set it, but I do like to be explicit about things, so we can just add it to a page anyway. So in our program class here, I can set the default scheme here and have a cookie handler, just to be clear and explicit about what we're doing in our application. So okay, so next we want to be able to sign in the user. So currently in my application, if we look at it, we do have a login page. The login does not really work. If I click here, nothing happens. And if you look at the code, my login code looks like this. It's pretty empty. And we can try to address this in the next bit. So how do we sign in the user to enable it to be logged in and to be able to access this secure page? So as we saw in Visual Studio, the code is currently empty. So what do we need to do in here to sign in the user? So the first, and also we do have a simple model object here to represent the username, password, and the return URL. So in our case, we will first, of course, when we receive the form post from a user with the username password, we will need to validate in our database. And for now, we just assume we do that. And the second step is, when to load all the claims from a database and create a list of claims. So we validate the username password, we look him up in the database, and then as a result back, we want a list of claims for this specific user. We create this list of claims. The next step is to create an identity, and we saw that before in the beginning, that the claims identity is the list of claims. We also specify how did the user authenticate. So we can, was it a Windows authentication, or was it a username password, or was it like something else that you can describe, because sometimes you want to know how did the user authenticate. So we create an identity. Next, we create our ClaimsPrincipal object, and basically we just have one identity, so we pass it into a ClaimsPrincipal object. Okay, so we create that object, and then we might optionally create an authentication properties object. It's more like a data object that contains, custom data that you might want to have in some case. And then we call the sign-in async. We can specify the name of a handler that should handle the sign-in, cookie in our case, and we pass in the ClaimsPrincipal object and these authentication properties. So what happens if we do that to our application here? So I will add it here to this method here. And we run it again, we start it. So now we will see the following, that I go to my secure page, me as a user is challenged, the cookie handler will redirect me to the login page, and login page, I just, accept anything, and then I'm signed in as Bob. We see hello Bob here. And if I click on Bob, I can see all the details about this user. So if we put the code here side by side, we see that we do have the claims in place. We do have those extra authentication properties in place. And we also get some other, how did we authenticate? He is authenticated. We get the name as well. So far, so good. We also see that it adds a few internal, authentication properties, like when did we log in, and when does this kind of information expire, for example. So that's good. And do we have any questions? Feel free to write in the chat. Okay, so we have signed in the user, and the question is maybe also what happens when we call sign in async. What happens internally? So when we use a cookie handler, as we saw in the source code, when we call, if we go back here, when we call the sign in, if we zoom in, we pass in the principal object and the authentication properties. So those two we send to the cookie handler, and that one will create a new object called an authentication ticket. And that ticket contains your claims principal, your authentication properties, and also the scheme, the name of the handler. That one is encrypted, and I will talk more about encryption later on. So it's protected, and we set the cookie in the browser, and optionally we redirect the browser to a new page, like welcome to your application, or some welcome page or similar. So these are the steps that happens inside the cookie handler. So if we go to application here, we can look in the browser, we can look at the application cookies here. We can delete that one. We see that we have an authentication cookie here, and that one is encrypted. It's kind of securely encrypted. We can't look inside of it. So it's like a black box at the moment. But we can actually look inside this cookie, I mean, the cookie itself. So how can we do that? Well, we can provide the cookie handler up here with a custom protection class or protection object. In our case, we create our own transparent, protection class that basically does nothing. So when we call the protect, we just return the input, and when we unprotect, we just return the unprotected data. And this is totally fine, and the cookie handler supports this. So we can actually go to our application. We can stop it here. We can add this very simple, protection logic. We go up to the cookie handler and we tell it to please use this one instead. And not that one. I should just copy it from the slides like that. Okay. So what happens? What's the difference now? Well, the difference is here now that when I sign in, we got some coffee, so just a minute. When we sign in, if we look at the cookie now, we get the cookie here. It still looks pretty kind of, scrambled. So how can we view inside this cookie? I mean, we add this kind of transparent protection logic here, but how can we make sense of it? So the thing that the data here now is actually just base 64 encoded. So we can actually go to base 64 decoding service, copy our cookie and decode it. And we will see that, yes, it is some binary serialization format, but we do recognize the claims and the properties that we used before. So if we go back to this page here, this one here, and if we compare it with what's in here, we see that it's basically the same thing. And that proves that the cookie contains your claims principal and your authentication properties objects in a serialized encrypted form. And so that's, how the authentication works out of the box. Does that make sense, I hope? Any questions on that? Just let me know. And I think it's really key here to actually look inside things, what's inside the cookie, for example. And that can be pretty interesting to see, that it contains everything about you that's in the cookie itself. So that's, I think, is pretty kind of neat. Okay, so sign out. What happens when we do a sign out? So when we click on sign out or log out, we will be calling the sign out async operation, and we tell the cookie handler to please sign out this user. That one will be calling the sign out, handler inside the cookie handler, and that one will basically just delete the cookie in the browser by setting the expiration date to some date in the past, like 1970. So in our case, it's pretty simple to add sign out to our application. So let's do that. We go back here and we go to our user controller. We have our logout method here. We just add sign out. We start it again. And we run it. And I should be able to log in. And then I can access the secure page all is good. I can see the details about the user, and I should also be able to sign out. Nothing happens here, but if I go back and we load the page, we see that we are logged out. So the sign out works, and we will kind of finalize the logout in a bit. But so if I log in, it works. If I log out, this page is broken. That's fine. We will fix that. And if I go back, I'm actually logged out. So that's, pretty good. But the question is why does not logout work? That we will try to address next. So we have, we call sign out async to the cookie handler, and we have specified the logout path. After logout, please go to logged out. But the response we get back from this is, it deletes the cookie as it should, but nothing else happens. There's no redirect. It's only 200 OK. There's actually no content. So basically, nothing happens. So that's weird. I mean, we specify the logout path. Why is this not called? That's weird. You Google, you ChatGPT, you Stack Overflow, and you read something about there's something called the return URL. So we could actually try to set it. So let's add it. We see that on some Stack Overflow. We see things that's should solve it. So we on the logout form here, we specify that when we log out, we go to the logout action method. We provide query string, return URL. Okay, so will that work? So let's try to see if that makes any difference. And in our case, we will see that it does not make any difference. If I do log in and I do log out again, nothing still happened. We do, however, see in the address bar up here, the return URL is specified. So almost good, but still does not work. So what is the problem here? Well, so this one does not even work either. We just did this one. So, what does this one do actually? You actually think that, as a beginner, you read the code, logout path, that is where you should go when you're signed out. But the problem is it's not correct. The logout path, we need to change it to /user logout instead. So this one controls that if so this is some sort of security feature, and that means that we only trust the return URL if we are on the logout path as specified here. So this one should be the URL of the page that do the sign out. And if those two match, it will actually take that return URL data up here and do a proper redirect to that one here. So that is, a really gotcha here that, it's really, really hard to understand what does it actually do. So this is only about controlling that if we only trust the return URL if the URL that we're doing it on matches the logout path as specified here, then the redirect will work. So in our case, we can go back to our program class and we can just change to logout as we do here. And if I do restart the application, we will see that the logout actually works in this case. So we sign in and we do logout, and you're redirected to the logged out page. So that's a small gotcha. You can also do it in a few different other ways. You can pass in the redirect UI through the authentication properties, or you can do a local redirect afterwards. There's a few different options here, but this logout path is only relevant if you want to use the return URL from the query string. That is when you need to set the logout path. Otherwise, there's no use for it, and you can otherwise use one of those two approaches instead. Does that make sense? I hope. One other thing that, okay, so far we're logged out, everybody's happy, but are we really signed out? So what happens if we take the cookie and copy the cookie to Firefox? Maybe the bad hacker here steals my cookie. So what happens in that case? So let's try that. We do log in here, logged in. We go to the Chrome browser here. We see my authentication cookie. We can go to Firefox. We can copy the same page. And, I should not, I'm not logged in here. And here I'm logged in. We see that. So that's good. Okay, so I can copy this cookie here. So I copy this one. I can go to your Firefox. I can add a new cookie. So I add that, add ASP.NET Core cookie. I also want to copy the value. I paste in the value in Firefox and just will load the page, and I'm logged in as Bob. Okay, but the problem is that if I now go back to Chrome, I do log out. I'm logged out, all is good, but I'm still logged in Firefox. So that is a problem, because the problem here with sign out that we do here is that we only delete the cookie. The cookie value itself, we saw before, we saw before that the cookie contains everything about the user, all the claims principal and authentication properties. We saw that here. So as long as that data is valid, time-wise, because there is an expired time, as we see some, traces of here, that cookie is valid in Firefox until it expires. So the hacker here with this stolen cookie can use it as long as the cookie is valid. And that is clearly not a good idea. And if you do want to solve that problem, then I do have a blog post that talks about how you can address that problem to ensure that the cookies are invalidated after sign out. But we don't have time to cover exactly how to do that today. And I will also provide those links in the material afterwards, so you will get that. So that's the key thing to be aware of. So to summarize, so far, we have talked about the authentication middleware. We can add handlers in that one, and in our case, we use a cookie handler, and that one supports 5 core operations. And we talked about the HTTP context that comes in, and the authentication and cookie handler will set the user object, the claims principal on this context, that then can be used to display the user on the page. So far, do you have any questions, or does it all make sense? Great. I want to talk about a second problem and do a deep dive about the data protection in ASP.NET Core. So it's an interesting small feature. So ASP.NET Core issues several sensitive items. It's the authentication cookie, we have the default cookies, we have a session cookie, we have, if you're using OpenID-Connect, there's also the state and nonce that is protected by the data protection system. And all of those places are protected by the data protection API in ASP.NET Core. This is all done, under the hood for us, so we don't need to do it, do it much, it's all handled behind the scene for us. So how does it work in practice? Well, so for example, if you want to protect your cookies, you have a key placed in a key ring. You provide that to the data protection module. And then, for example, if you want to encrypt your user data, you can send your data to the protection, and it can then, issue a cookie that is then, secure and encrypted and protected in different ways. And then when you send back the cookie to the browser, to the application, it can unprotect it and get the data back, and then you can use it in your application. That makes sense. So just to kind of demonstrate it, I do have a separate application for that. So I will close this first one, and then I will go to second application just to talk about the data protection. So in our case, we use a bit more features here. We use Aspire, for example, to start this application because it consists of 3 different services. I will come back to that, but for now we will just go to one of them. And here I do have a simple protect and unprotect page where I can, for example, have hello as an input. I can encrypt that information. I see the encrypted data down here, and then I can do a decrypt, and I get back the hello here. So that's very kind of simple how the data protection system works. You can take some input, protect it, and then you can unprotect it and get the data back. And this one is then secured using some key. Okay, so that makes sense, I hope. Okay, we can protect the information. But when we talk about when we kind of go to production, we start to see warnings in our logs, like, key was not found in the key ring, unprotected operation cannot proceed, cookie was not authenticated, unprotected ticket failed. What is going on? So let's try to demystify and explain what happens under the hood. So in our case, we want to use a load balancer, and we want to have 2 different instances of my application. So I can send in a request with a cookie. This one should be representing my authentication cookie, as you saw before. And then I do a load balancer that can randomly, call one of the 2 instances. So, okay, that's a setup here. And then, of course, the question, what can go wrong here? Well, a lot of things. First of all, that one problem is that when we redeploy, users might be signed out. They lose the session, the cookie are invalidated. We can have a problem with that the cookies are not recognized across those 2 instances. It can also be the key management of the keys that we use to encrypt the cookies. So we do have a lot of things to be aware of and handle and configure to get a working system. So let's kind of first go back to my application here. So we're using Aspire And that allows me to, in a very kind of neat way, launch several applications at the same time. I do have a load balancer here, and I do have 2 instances running. And if I go to the load balancer, I should see that when I reload the page, I should be jumping between, service 1 and service 2, like that. And the goal here is to sign in as a user. So if we are on number 1, we do a login, same as before, more or less. I'm logged in, awesome. So I'm logged in into a first service. But if I then go back here to the load balancer, I think I had the wrong one. But anyway, we see that one is kind of signed in, but the other one is not signed in. So we want to kind of figure out why is the cookie not working across those 2 instances. We want to have a seamless, that the cookie is accepted by both. And if we go to the number 1, in this case, and look at the log, we should see those arrows. If we zoom in here a little bit, unprotected ticket failed, failures. It does not recognize the cookies are not accepted by this service, and that's why we get these errors. Okay, so let's try to figure out why this does not work, and let's try to get it to work as we want. Okay, so what is going on here? So by default, and maybe we deploy the containers or in production, we deploy those 2. By default, they will create their own separate protection key, the encryption key that is used to encrypt the cookies. And by default, that is stored on the local disk. So on Windows, you can go to that path, and I can, and here I can see I do have a lot of keys. I can, so let's do, so I can actually delete all of those keys. I can restart my application, and we will see that it will create a new key for us. And that key is actually an XML file. So if we look inside this file, it's actually, let's open it in Notepad++. That file is an XML file, and that one contains the key here, and it has a 90 days lifetime, and after 90 days, the key will be regenerated by ASP.NET Core and the data protection subsystem. Okay, so that's my key. So it's created by default by the system at startup. But that's good, it's convenient, but it's a problem. And the problem is that if you issue cookie from service 1 to service 2, that one will not be accepted because those 2 keys are different in this case. So that's a problem. And also a second problem is that if you redeploy maybe to a container in the cloud, you get version 1, it creates its own key, it issues a version 1 cookie, but then you deploy version 2, it creates a new key because the key does not exist. Then version 1 cookies will be rejected by version 2. So all existing signed in users will be signed out and have to sign in again. So clearly, this default behavior is not good enough for production. We need something better. So what do we do here? Well, we need to ensure that the key that we use to sign those, to encrypt those cookies are stored in a more permanent, persistent store. And that can be a database, can be blob storage, can be Azure Key Vault, it can be Redis, it can be on disk. It's up to you, but it should always be persisted, and and the same one should be used all the time to ensure that we have a seamless deployment and that we can get, the cookies are accepted across our two services. So in our case, we will, on both our instances, just to kind of demonstrate, we can actually choose a path where to store it. So we do this in both our services, and we choose the cconf keys folder in this case. So we can actually go to that folder and we can just go in here. We can delete that key that is already in place. And then we can go to our application and we can add a logic here. And we just need to, and we do it for the second one too. Like that. So we just say that, we want to persist the keys to the file system on that path. And if I were to restart the application, we would see that in this conf keys folder, the keys should appear when the system starts up. Did I start it? Hopefully. Yeah, it's starting up here. It will create some keys in this folder when they should pop up here, and there should be a key here. Yeah, here's the key. So this key is now used by both services. But even though I'm using the same key to both systems, and I do log in to one of the instances, I still, don't get that both services accepts the cookie. So it still does not work, even though I now have ensured that both instances are using the same encryption key. Okay, so next we need to understand and master the purpose, the magic purpose. So what is that? Well, so we have a key, and that one is the thing we see, stored here. That's our key. That key, we don't use this key directly. We never do that. Instead, we use a key derivation function together with our purpose to generate a new key. Okay, and that one we use to sign out, to encrypt our cookies. What's the purpose of this? Well, we can use the same approach for different purpose. And the thing here is that we can create like isolation, but cookies issued by the sales system cannot be decrypted by the order system, for example. So it's a way to have one master key, but then we can restrict that and create kind of subkeys based on this master key that we can restrict, its kind of scope. So that is the purpose. And if we go back to our application here, let's go back to our, I open it. So I go to number one. I do have this protect, so we do hello C#. I can encrypt it here, and I can specify my custom purpose string here. Okay, so that's good. I copy this, encrypted data to my second instance. I go to the same method, I do the same purpose, I have the same content, I decrypt it, but it does not work. That's odd. The purpose is the same, the key is the same, but I can still not decrypt it across, those two instances. That's odd. How do you fix that? Well, the problem is that the purpose needs to be the same across both instances, but the secret is that ASP.NET Core adds the path of the application as a purpose as well, and you can have multiple purposes to your key. So each time, if you use this, session middleware, it will kind of add the path to the application plus the purpose session middleware. Or if you use the cookie handler, it uses 4 different purposes. The path, the kind of name of the handler, the kind of scheme, and also version. And if we look at in our example, the customer data, we are using the path as well. And in our case, the 2 applications that I do have here in my solution are on different paths. So that's why data from one service can't be read by the second one, because the path is different between service 1 and service 2 in this case. So what you need to do is to set the application name to a common name, like my application. That sets the purpose. And if I were to do that, I go back to here. I set the application name as well. I do that for both. So they share the same, purpose. And I will start the application. And now I will be able to let's start it up here. So this comes here in a bit. Okay, so I have my up here. So in this case, so if I go to the first one here again, I protect some data like hello USA, like that. We have the same purpose. We copy the data. We go to a second one, and I want to decrypt it. It did not work. The key was not found in the keyring. Did I miss something? No. That's odd. I need to think about that. Why did that not work? Okay, so let's try the second thing. Let's try to sign in across the 2 services and see if that works. So now I am on the kind of load balancer. I sign in on one of the instances. I go back to the load balancer, and no, it does not work. Still not work. Let me see. This one, application name here. That one is 2. Let me just restart it again to see if I missed something.
Did you recompile both of them?
Yeah, I did that. So let's try again. Let's do a simple approach here. I protect some data. Hello, encrypt it. I can go to the second one. I want to decrypt it here. No, doesn't work. So if I look at the log for the second one, we should see that protect operation, purpose, my application, and if okay, that one, bounce the key. So default cookie was not authenticated. That is a bit odd. Here's an exception here. Do you see where I said the cookie, the token? Default token decrypted. Anyway, I need to look into that. I don't know exactly why it complains at this moment, because from my point of view, that one should work, because now our purpose is my application and the name of module, but this error here was not found. The key was not found in the key. It could be that we have some old cookies hanging around, so we could actually try to ensure that we don't have any old cookies in place, because that can also interfere. So if we go to number 1 again, we encrypt some data. We do just that. We okay, so now we encrypt some data. We copy it to number 2 and paste it in here and decrypt it. No, it was not found. It says the key not found in the key ring.
Did
So
you clear the cookies also for 2?
it's
Or
on the
this- it
same.
was on the
It's on
same
the same
site?
host. It's the same host, so they
Yeah.
share the same cookies in this case. So that is a bit odd. So I don't really understand that, because we have the same key. We could skip that part and use the default path, but that one should not be, does not matter in this case. And we have the same my application in both places. That one. The path temp conf here. That's a problem, you know. So let's go back to the this approach. There's a bug in my when I copied it, I had not the conf on both places. So now try it now. Okay. So
Do we need to tell set the application name?
I have a wrong path here. Should be conf keys, and I use the same one on the here. So that was the problem. It was not the same path for the keys, so it was a bit confused. So now let's try it again. It's always nice to fail together here, you know. And so in this case now, we share the same key in both places. And if I go to the first one and I protect some data, hello, what? Okay, I think it just hello, encrypt. I get the data. I go to the second one. I decrypt it here, and it works. Yes, good. And that means that now the data from one instance can be kind of decrypted by the second one. And that also means that if I go to the load balancer example here, I sign in to one of the machines, and then go back to the load balancer. I should see that I'm logged into both, and I use the same cookie in this case. I go to the load balancer and I see different instances, and the same cookie is accepted by both services. So the final bit of the day is that by default in this setup, both instances wants to create. I mean, if we might end up in a race condition here that both wants to manipulate the keys in our that is stored in our key ring in this case, That might be create some unexpected behavior. And to prevent that, you can actually say that one should be like read only. So in this case, we disable the automatic key generation, and it can only then read keys, and it will not kind of interfere by creating keys or revoking keys or similar. So that is also something to think about in production, who manages the keys. So, and that is a new feature in .NET 9 that allows to disable this creation of a key at least. Otherwise, you might have some race conditions. So that's my end of my presentation. I will upload the source code and the code to this project here. And I will also send to Rob when it is in place, all the links I have shown, all the code, everything will be provided on this link. And feel free to connect with me on LinkedIn and check out my blog and my work. And if you do have any questions on today's presentations, feel free to email me as well. And you find my email on my blog. Do we have any questions?
There's one in the chat
Yes.
as other people marinate.
Yes. Authenticator apps. Then you need to go to talk about the. Okay, so yes, you can do that. You can incorporate multi-factor applications in .NET Core. Most of the time, you might start with the ASP.NET Core identity library. That library supports a lot of the infrastructure for doing multi-factor authentication, and also then there's also a library that you can use. What's the library of that one? There's a website called webauthn.io. Let me see. Yes. And it lists all the different libraries. So if you want to talk to your YubiKey or hardware key or use a kind of passwordless, there's a library that can use to talk to your hardware device, for example. So yes, you can incorporate it, but that is always some work. But it's doable. Any other questions?
Last call on any questions before we do the closing remarks and prizes. Awesome. Thanks a ton, Tor. Appreciate that.
Yes.
I'm going to share some slides eventually. I just want to give people time